Hello everyone. Today we'll be solving question number 1 uh, from IOA 2025 theory. Question number 1. So in this question it is about Daksha mission. Uh, Daksha is a proposed Indian mission consisting of two satellites S1 and S2 orbiting the Earth in same circular orbit of radius 7,000 km. So the radius has been provided of a 7,000 km, but with the phase difference of 180 degrees. So I can say that my delta phi is 180 degree. This satellite observe the universe in high energy domain, which are X rays and gamma rays. Each of the satellite of Daksha use several flat and rectangular detector. To understand how to localize a source in the sky, we shall use a simplified model of a Daksha mission. Assume that S1 has only two identical detector. D1 and D2, each of area 0.50 meter square. So two detector, I can say two detector, and then area 0.50 meter square, attached to a opaque mount M as shown in figure below. Okay, so these are two detector. This is an opaque mount. The detector lies symmetrically around y-axis in a plane perpendicular to xy plane. So detector plane uh, detector plane uh, is perpendicular to xy plane, and then angle between them is 120 degree. Okay, this is obtained from the question, and my first part of the question states that when observing a distant source located in xy plane, the first point is a source is located on xy plane, right? Okay, and then detector D1 record a power P1 of a, so for D1 my power is 2.7 into 10 to the power minus 10 joule per second, and similarly for detector D2 the power is 4.70 into 10 to the power minus 10 joule per second. Now the question says that we need to find the angle eta made by the position vector of a source. Okay, so the position vector of source with positive y-axis, with counterclockwise angle from positive y-axis being considered positive. Okay, so I need to find the angle made by the position vector. Okay, so this is a vector question. So there is a concept of a resolving a vector. Suppose and this is my x, this is my y, and I have a vector a. Now since the question says that I need to find the angle from positive y-axis, I will consider this angle. Many students must have learned when they put angle theta at this point, but we can also put angle in this point and resolve it, so it's the same concept. So now when I can resolve this vector, I can resolve the vector in this uh, in y-axis, right? And similarly I can resolve this vector in x-axis. This is one point and this is another point. I can resolve this vector, right? So the angle theta, theta can be written as tan inverse, so this, which is ax and ay, and this is my ay and this is my ax, right? I can write this now, but the question says that the counterclockwise angle from positive y-axis being considered positive. That is, I need to make a symmetric vector a here, and then this theta is positive. So my questions is that I need to find the angle when this is the case. I need to find this. So for that I need to find a position vector of a source. So how to find position vector of source? That's the whole question. Now if I have unit vector which points toward the source, and we know unit vector gives me direction. My unit vector give me direction, right? And if and resolve unit vector in let us suppose my s is unit vector, and then resolve it in sx, sy, and then eta will be tan inverse minus sx minus sy, right? This is the condition that will be used for the finding uh, angle from the source. Okay, so now how to find unit vector? So what is s then? Okay, now when we look into the question, you said that we have been only given power of detector D1 and then power of a detector D2. So power is given by A effective flux, that is A effective is effective area, F is a flux of source. Now if I look into the figure, this figure provided an image, it is said that detectors lie on a very perpendicular to xy plane, and then they make a angle 120 degree. So in 3D, if I make an image in 3D, it would be mostly if this is y, is this is my x, then and this is my z. My detector would lie as this. This is not a perfect image, not exact image, but to make you but it's a conceptual one, conceptual image. So my area, a unit normal vector for a detector, will always lie in xy plane. How can I prove this? If NP is unit normal vector of detector and xy is unit normal vector of xy plane, np dot ny xy equals to 0. Since nxy is 0 0 1, NP will have two components of nx and ny, and this would be 0. That is, my NP, the unit normal vector of a detector, will always lie on a plane nx and ny. So n can be resolved at nx I cap ny j cap, where I and j are unit vector along x and y axis, right? Now, why am I finding, so the question might arise, why am I finding the unit normal vector of a detector? Why? This is because the area effective is a projection of a area. Area effective is projection of a area in direction of a source. Suppose you are given, so for example, I can say that this is my detector. This is my unit normal vector, and a source is present here, and it is, and this is my direction of a source. Now, to find the power, we need to find the projection of a detector on within direction of a source. This is exactly as electric flux. Electric flux. Here in electric flux also, this is my electric field. This is my unit normal vector, and this is my electric field. Now you take a dot product of a area with electric field to find the electric flux. It is simply saying that I am finding a projection. In direction of a electric field. This is happening in that case. So similarly, now there is an angle between my detector and between the source. So for that, I need to find the area effective. So power P1 can be written as area effective times flux, and power P2 can be written as area effective times flux. Correct? Now area effective would be area, the normal vector, the unit normal vector, and then source, the direction of a source. So I can simply write AF, and then, so if I say N1 is unit normal vector for source, detector D1, and then this can be written as N2 cap, then S cap. Now we have been given P1, we have been given P2, right? My flux is same, my area is same, and if I can find N1 and N2, I can make a equation which will help me get unit normal vector Sx, right? So how to find a unit normal vector? the unit normal vector, if I look into the image, if I look into the image, I can simply say that uh, for d1, my unit normal vector n will be cos theta I cap sin theta j cap, right? And then for d theta d2, so it's n1, n2 will be minus cos theta I cap sin theta j cap. If I look into the image, I can simply take this angle as a theta and then resolve the unit normal vector there. So it would be cos theta is 60, so it should be 1 by 2 I cap root 3 by 2 j cap minus 1 by 2 I cap root 3 by 2 j cap. So now I got n1 and n2. Now s dot n1 would give me what? 1 by 2 sx plus root 3 by 2 sy. S dot n2 would give me minus 1 by 2 root 3 by 2 sy, right? And this is equal to af, this is also equal to power by af p1 and then power 2 by af, correct? And this is also a normal vector. So if I solve this, I can get these are, so now you got two equation, equation 1, equation 2. Now af is same, you know the value of p1, you know the value of p2 which has been provided. This is a quadratic equation, two equation has been provided. We can get sx and then sy, sx and then sy can be calculated simply by substituting the value, right? And if I find the eta is tan inverse sx and sy. If I substitute the value turns out to be some 25.1 degree. Now part 1 of the question has been completed. Now the part 2. Consider a single pulse from a distant source, not necessary in xy plane, recorded by both satellite S1 and S2 of a Daksha. The time of the peak of the pulse recorded by S1 and S2 are T1 and T2 respectively. If T1 and T2 was measured to be 10 plus minus 0.1 millisecond, then determine the fraction of a celestial sphere where the source might lie. Okay. So now the question says that there is a single pulse from a distant source, and it is recorded by both satellite S1 and S2. The time of the peak of the pulse recorded by S1 and S2 are T1 and T2. So there is a time delay. So why it can be a time delay? Suppose this is for a part 2. Suppose this is my source. This is my source. Sorry, detector. And if this is my source, it will emit electromagnetic radiation. So to make it more clear, I will assume this and this so that it's easy to analyze. the this is my electromagnetic radiation from source, and the source is presented here. It's far away, so it's very far away, so it's coming the electromagnetic radiation is parallel, so it comes from very far away. So, and this is uh, how this observer, this source detector, so this is S1, so this is S2, and as you can see that there is some delay. uh, this need to be perpendicular. So as you can see from this image itself, there is some delay. There is some delay when you are observing a signal from a source, because the distance between the source and the detector, distance between the source and the detector are not same. So because of that, there is a power difference associated. So you can understand. So in this mission itself, I can say that since there is a phase difference, since there is a phase difference, let one satellite is at that point and another satellite is at this point. This way S1, this way S2. They are moving in a circular orbit and their phase difference is 180 degrees, so they are opposite to each other. We know delta phi is equal to 180 degree. So I can write this. Now my source is presented here, and my source is present. If my source is there, source is not a point particle, please do not consider it. I just want to make sure to understand it. So it's a source, to just make you understand I am writing this. Now from a source, S1 also, so from a source S2 and S1, they both observe, and then if I am observing a light, there exists a power difference. There exists a power difference. Now this is my path difference. This will be my path difference when you are observing. So to make you more clear, if this is presented here and then a light is coming from this angle, and then so this this would be theta as well, this would be theta as well. My source is here, source lie here, and then I can simply connect this, and this will be my power difference. This will be my power difference, right? So there will exist some power difference presented in there. Now path difference can be given as C delta T. If T1 and T2 are time taken, I am observing a light, there exists some delta T. So in that delta T amount, it must have uh, if at it must have moved this much part, so I can simply write part difference as C delta T. Similarly, from geometry I can write part difference at 2r cos theta. This is 2r, this whole distance, so I can write this as part difference as 2r cos theta, correct? So I can write so my cos theta would be C delta T 2r. So my theta can be written as cos inverse c delta t to r. So if I can find delta t, that is difference in time while observing same source by two satellite. If I can find that, then I can say that uh, I can calculate theta. So if I look into the question, so if you look into the question, T1 to be measured to be 10 plus minus 0.1. So there is uncertainty, that is there is uncertainty in T1, uncertainty in delta T, there is an uncertainty present. So there must be uncertainty, that there must be some theta 1 and theta 2 present, which will be associated between uh, which get associated because of the uncertainty in delta t. So my delta t is 1, delta t can be 9.9 millisecond as well, and because of the uncertainty my delta t can be 10.1 millisecond as well. And because of these two value, because of these two value because of these two value of delta t, I don't get a single theta 1, I get a theta 1 and theta 2, right? So theta 1 is cos inverse c 10.1 to r, and theta 2 is cos inverse c 9.9 to r. So if I perform the calculation, I get 77.5.8 here, 77.76 degree here. So because of the uncertainty of the delta t, because of the uncertainty in delta t, uh, there are two delta t value, which is 9.9 and 10.1, and because of that there are theta 1 and theta 2. So now if there was no uncertainty, we can say that sources lie on exactly theta value, but because there is an uncertainty of I can say that the source lie between theta 1 and theta 2. There is no single point, there is a point. Because of the uncertainty, a strip has been made which cover theta 1 and theta 2, and it can lie in any of the axes. So if I make a celestial sphere, and then if this is my I can sorry, if this and this angle, so if my theta 1 and then theta 2, I can simply say that there lie a strip, there lie a strip between this point. So there is a strip between this point and this strip where my sources lie. So my source is in this region, right? This is an In this region, my sources will be presented. So uh, the question asks to determine the fraction of the celestial sphere where the sources might lie. So I need to find fraction. That is, I need to find fraction in celestial sphere where uh, source lie. Right. So the fraction is area of the shaded region. I can say annulus has been created divided by area of a celestial sphere. This is what I need to find. If my radius of celestial sphere is 1, area is 4 pi. Now area of annulus will be 2 pi cos theta 1 minus cos theta 2. F equals to 1 by 2 cos theta 1 minus cos theta 2. It's turned out to be 2.13 into 10 to the power minus 3. So now the question might arise, how you get this 2 pi cos theta minus theta 2? It is nothing, it is just a standard formula, that is a surface area of a polar cap. Surface area of a polar cap or a spherical cap. Spherical cap surface area is just given by 2 pi r square 1 minus cos theta. So if I substitute this cos theta value, you can simply get that this theta, and then for spherical cap, I can get a value of a 2 pi r square 1 minus cos theta. This is standard formula, or you can just simply do integration, or you can simply do integration, add it and calculate this, or you will get the same formula. So if I substitute theta 1 and theta 2, if I do value for theta 2, I get this formula, and then I can simply divide it.